Hello, this is Alicia and today we'll be covering some counting and probability, but before we move on, we will need to know some basics about numbers, such as how many integers there are, maybe when between 1 through 10, which is 10 integers, or maybe between 0 to 10, that would be 11 integers. But what if we have a lot of numbers and we can't really count the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to find the number of integers? Well, we have a really simple solution, which you multiply the end number, which in this case is 10, minus the beginning number, which is 0, plus 1, which is 11 integers, and matches up. Similarly, we can do the same between 100 to 0 to 500. We have 500 minus 0 plus 1, which is 501 integers. Another really important thing we must know is how to add the sums of numbers, which maybe like here, 1 to 9, adding the numbers, we could add it like 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9, but we don't always have a calculator, and it might get to a point where there are too many numbers to add up manually one by one. So an easy solution we have is to add 1 to 9, which is 10, 2 to 8, which is also 10, 3 to 7, which is 10, and 4 to 6, which is 10, and we have 5 left over. So right here we have 1, 2, 3, 4, 4.5 because of this half times 10, which is the sum that each pair produces, which leaves us with 45. And in many scenarios, we don't just limit counting to integers. We usually count things that are like fruits or outfit combinations or sandwiches. For example, we have an example which is number 2 here. Suppose the list of pizza toppings is pepperoni, sausage, green peppers, onions, mushrooms, and alfalfa sprouts. How many different 2-topping pizzas are there? Well, we can make a combination with alfalfa sprouts and pepperoni, or alfalfa sprouts and sausage, or alfalfa sprouts with green onion, green pepper, and alfalfa sprouts with onion, or alfalfa sprouts with mushroom. Likewise, we can do mushroom with green onion with onion, mushroom with green pepper, or mushroom with sausage, and so on, which we can efficiently list here with pepperoni, sausage, and mushroom and sausage, and mushroom with onion, onion with green pepper, and so on, which we have 1 plus 2 plus 3 plus 4 plus 5 different combinations, which brings us to 15. And if we want to make a tree diagram, it will look like this, and tree diagrams are usually used when there are many possible combinations which can be listed in a more efficient manner. And if we wanted to write it with a technical manner, it would be 6 choose 2. And another example I have today is if I want to choose different outfits to wear at school, like I would have green, purple, white, blue, or an orange shirt, or I would wear a skirt or shorts, and I would wear either sneakers, sandals, or boots. Today I could choose a green shirt, skirt, sandals, or I can choose sneakers or boots, which would give us 3 options. Or instead of wearing a skirt, I could wear pants, and so on. And if I wanted to make a tree diagram, I would put my shirt over here with my 2 options being the skirt and the pants, and sandals, sneakers, and boots. So here it would be here and down here, and doing so would give 5 options for shirt, 5, 2 different options for between skirt and pants, and 3 different options for shoes, which would give us 30 different outfit combination. Also, you might be wondering what the difference between combination and permutation is. And so permutation is when order matters, combination is when order does not matter. And like permutation is if you want to choose like how you want to order some people to walk in during graduation. But combination is just choosing some specific number of people to walk there in no particular order. And these are the 2 equations between permutation and combination when you are told NPR or NCR, which K is the R in this case. Sometimes with permutation, you're told to order a word in a specific, with different arrangements. So with word, for example, you can put it like word like normally, or WROD, WOR, DRO, or DROW, or ROWD, etc. And with this is permutation with 4P4. So using the equation we had from earlier, which is n minus k, we have 4 factorial over 4 minus 4 factorial, which equals 0 factorial, and we know that 0 factorial equals 1. So this essentially is 4 factorial, which is 24 arrangements.
So here are 5 different problems I've selected for you to try, and please pause this video and continue when you're finished so that I will quickly review the answer before we move on to probability. So for number 1, we have to find the arrangements of letters, which can be found as 1, 2, 3, 4, 5, 6, 6p6 over 2, because there are 2 of the same letters, which is D, which would be 6 factorial over 2, and 6 factorial over 2 is 720 over 2, which would be 360 number of arrangements. For number 2, we have icicle, which is 1, 2, 3, 4, 5, 6, again 6p6 over 2 factorial times 2 factorial, which would be 6 factorial over 4, which this time would be 180 possible arrangements. And next we have how many ways can 5 books be ordered from left to right, which is 5p5, which is 5 factorial over 0 factorial, and that is 120 possible arrangements. For number 4, we're asked to find how many different sets of 3 books can be chosen out of 20, so in this case it would be 20c3, and with the equation that we are given here, with this, we can see that. And for number 4, we're asked to find the different sets of 3 books that can be chosen out of 20, then, which would be 20c3. And using our equation which we have over here, we can see that it is 20 factorial over 3 factorial minus 20 minus 3 factorial, which is 7 factorial, which would be 20 times 19 times 18 times 17 factorial, and 3 factorial times 17 factorial, which would cancel out here, which would give us a total of...
And at the end of the video, I will give challenge problems that you can try, as well as link the answers there after you pause the video. But moving on, we will be talking about probability of an event. So probability of an event always lies between 0 and 1, and when it's 0, it definitely won't happen. When it's 1, it definitely will happen. When you were talking about or between different variations, then you would add the probability of 2 events happening, because only one of them has to happen for this effect to be true. When it's and, they both have to happen, and both events have to occur, which makes them a multiplication between the 2 probabilities, because even if one happens, the other may not be true, which would not make the equation valid. Underneath in red, I also wrote the technical equation that we would use when determining these factors. When two events are independent, like the result of the first has no effect on the second. If two events are dependent, the first result affects the outcome of the second. Many probability problems also involve blind selection of objects. If objects are selected with replacement, the events are treated as independent of one another, and if they're selected without replacement, they are dependent events. So in terms of coins, we have head and we have tails. Some questions may ask how many times would I, if I flipped a coin maybe 2 times, what are the odds that I will get heads both times? Which, let's try tails, nope, and tails, which it wouldn't be. But in many situations we can write like heads. Well, we have either heads or tails, so we have a 1/2 chance of getting heads the first try, times 1/2, which is 1/4. And in order to get heads both times, this is a and conditional statement. So if we were to get heads like either time, then it would have been 1 well, like it would be either HT, HH, TH, or TT. So with that would be 1/2. Well, that would be not 1/2, sorry. That would be 3/4. You would either get heads at least one of the times, or you would not get it at all. As for cards, we know that we have 4 different suits: hearts, diamonds, clubs, and spades, and each suit has 12 cards in each. So that would give us a total of 52 cards. Maybe some questions would ask things like, oh, like how many, what are the odds that if you choose from a deck of cards, you will get like a red suit? And since 26 of the cards would be red, then the odds of you choosing some red suited card would be half. And they would ask similar questions like that, so just be prepared for that. And finally, we have like dice questions, which would be like, if I had a dice, what are the odds that I would be able to roll maybe like under 3? So you can roll, and that's 2. So the odds of me choosing a dice, of me rolling something under 3 would be either 1 or 2. So that would be 2 out of 6, which is the total possible over whatever you get, like whatever true combination that we learned from earlier. You can do the same with 2 of the die. Maybe you would be asking for a sum, maybe a sum under 6, or maybe 3, and you're asking if all of them would be like, would roll a 1, and etc. So these are the practice problems I want to do. I will link the answers up after I finish, and thank you for listening to my video about probability and counting.